Today's lesson is section 4.4 and it's parallel lines and perpendicular lines. So let's refresh our memories about both of them. So parallel lines are two lines that never intersect, and more importantly for us today, that they have the same slope. Okay, very important for today. So our symbol for parallel lines is two parallel lines there. Perpendicular lines, they are lines that intersect to form four right angles, and we're going to talk about their slopes here in a little bit, but their symbol looks like an upside down T, okay, to show perpendicular. So moving on to the chart, it says two lines are parallel if and only if they have the same slope. Okay, we've gone over this before, we've found slopes of parallel lines, and it has to be 100% the same. So looking at these two lines, we can see that they're parallel graphically, but then algebraically looking at their equations, I can look at the slope and say, hey, even if I didn't have the graph, I would know that these two lines were parallel because they both have the slope of 3. Perpendicular lines do not have the same slope. Okay, so two lines are perpendicular if their slopes are opposite reciprocals. Okay, so remember, opposite reciprocals, opposite means if it's positive, it becomes negative, and vice versa. Reciprocal means if we have a fraction, we flip it. So numerator becomes denominator, numerator becomes denominator, and denominator becomes the numerator. So comparing these two, I have negative 1/3 as my slope. The opposite of the negative is a positive. The reciprocal of 1/3 is 3. It would also work if I started with 3. Positive 3 would become negative. Remember, we can make any whole number a fraction by putting it over 1. So then if we were to flip it, it would become 1/3. Okay? So our first example, we're going to do two different things. So it's sort of like two examples in one. It says to write the slope-intercept form, so slope-intercept form, y equals mx plus b, for an equation of a line that passes through 4, -1 and is both parallel and we have to do perpendicular to that graph. So this problem is going to be the longest problem we have because right now I'm looking at this and I'm seeing that it is in standard form. And I know that if I have to write an equation in slope-intercept form for something that is both parallel and perpendicular, I need to know the slope because I'm going to work with that slope for my new equation. So let's start off with parallel first. All right, and then I'm going to do perpendicular over here. I'll do the darker green. And then right here in the middle is where I'm going to take this equation and rewrite it in slope-intercept form. Because in standard form, I can't tell what the slope is. It either has to be in slope-intercept form or point-slope form. So we're going to do slope-intercept form. So my goal is to solve this for y. So negative 2y equals negative 7x plus 3. Divide both sides by negative 2. I will write this out. So it actually becomes y equals 7/2x minus 3/2. Now we need one piece of information from this equation, and that is it. Okay, we need no more information. The only thing we need from this is our slope. Okay, so I'm going to write that down. My slope is 7/2. My perpendicular slope is negative 2/7. Okay, and we don't care about anything else on this equation, so we could practically just cross that off, that work off. This is all we care about for now. So my parallel slope, I now have my slope, which is 7/2, and I have my ordered pair for -1. So now we're going to write the equation of a line. You could start in point slope form if you wanted to, like we did the day before, but I'm going to go ahead and do slope-intercept form. So -1 equals m, which is 7/2, times x, which is 4, plus b. I'm going to reduce this, and then we actually get that b is -15. So the parallel equation is y equals 7 over 2x minus 15. I don't know why that's being weird. Minus 15. There we go. So part A is done. Moving along to part B, it's going to be almost the same exact problem, except this perpendicular slope is negative 2/7, but I'm still going through the same ordered pair. So xy, so negative 1 equals negative 2/7 times 4. I'm going to put 4 over 1. So negative 8/7 plus b. I have to add 8/7 to both sides. So look, I know some people get worried about fractions. I know in class they chose to multiply everything by 7, which is fine. But I can do negative 1 plus 8/7. I don't want the decimal. Let's do a fraction. So we'll math enter, enter. We get 1/7 as b. So this final equation is y equals negative 2/7 x plus 1/7. Okay, so it's like what we did when we were writing the equations, just basic equations in slope-intercept form, except I first need to find my slope. Okay, so that's the basic principle for everything we're going to do today. And the hardest problem, because sometimes if we look at the next example, notice how the equation they gave us is already in slope-intercept form. So we don't even need to do that step right there. Okay, so let's take a look at the next example. It says, write the slope-intercept form for an equation of the line that passes through 4, 2 and is parallel to that line. So if it's parallel, my parallel slope is going to be the same, and that slope is 1/2. And it has to go through the ordered pair 4, 2. So again, x and y. So we get 2 equals 1/2 times x, which is 4 plus b. Half of 4 is 2. Whoops. Plus b, not equals b. One step ahead of myself. And then b is going to equal 0. And you're probably thinking, it is okay for b to equal 0. Just means my graph is going to go through the origin. So we have y equals 1/2 x. You could put the plus 0, but it's not necessary. You could just do y equals 1/2 x. Okay? Either way. All right, example 5. Same thing, write the slope-intercept form for an equation that passes through 4, 2. Oh, but this time it's perpendicular to the same equation. So I don't want to use the same slope. So I'm going to write my slope down first because that's all I care about. And then I'm going to ignore the equation. So ignore it like it's not even there. That way we're not tempted to use that b value. But do remember, if you use the same slope and the same y-intercept, it's not two different lines, it's the same line. So now my perpendicular slope, it's positive, so the opposite is a negative. The reciprocal of 1 over 2 is 2 over 1, which is just 2. And we're going to cross that off. And it goes through the point 4, 2. So then we have 2 equals negative 2 times 4 plus b. And we get that b is 10. So this final equation is y equals negative 2x plus 10. All right, so there's how we write the equations of both parallel and perpendicular lines.